Alright, Chapter 3, Study Guide, Limits, Problem 2D, the last of our piecewise continuity function problems. So let's go ahead and hammer this one out, get it over with. Okay, we're told that when x equals 3, it's going to equal whatever that is when we find out what k is. And we want it to be continuous, so we need the limit as x goes to 3 to equal that. So we're going to go ahead and write ourselves a limit function. Let's figure out the limit of this function as it's heading to 3. So we write the limit as x goes to 3 of x cubed minus 27 over x minus 3. And we need to factor this. Now, it's a pretty big hint that we have x minus 3 in the denominator. That might make you think there's a good chance that x minus 3 is going to be a factor of our numerator. But if you're feeling fancy, then you could recognize that we actually have a difference of cubes problem. And so we can rewrite that as x minus 3 times x squared plus 3x plus 9. If you don't know the formula for difference of cubes, that's okay. You can use synthetic division with the 0 of 3. And our function would be x cubed plus 0x squared plus 0x minus 27. And then you could figure it out this way, and it would be a whole lot of fun. And we would again get x squared plus 3x plus 9. So whichever way you need to do it, totally fine. And again, all of that over x minus 3. So you can see we're going to have a hole at 3. So let's rewrite this as the limit as x goes to 3 of x squared plus 3x plus 9. So we can just directly evaluate this. So we get 3 squared plus 3 times 3 plus 9, which is a fancy way of saying 9 plus 9 plus 9, which is a fancy way of saying 27. So this function, the limit of that first part of the function is 27. So our function is headed to 27, so we just need to set that bottom part equal to it. So 3k squared equals 27, and so we get k squared equals 9, k equals 3, and we're done.